Okay, welcome back. Bear with me while I get set up. Okay, bear with me while I just try to get set up here. Okay, right. What I want to look at. Welcome to Terence Payne Electrical Engineering. Okay. Now, what I'm going to look at is electrical machines and motors. Okay. Electrical machines, motors. City and Guilds 2330 level 3, Unit 1, Outcome 6. Now, bear in mind that these units have been taken some time ago. So Unit 2330 that number may have changed, but the technical knowledge is still relevant to this day and will always be. Okay. You can apply this information also to City and Guilds 5357 or the 2357. Okay, that is also applicable in this case. Right, let's look at the content we're going to be looking at. This is a simple machine here. Okay, and it's purely my front line. Well, I call it my front line. Okay. Hang on a second, bear with me for a second. Let me just see if I can get him to come up piece by piece. Nope, okay. Bear with me, just checking to see if I can do it. Okay, well not. Now, you've heard me talk about something about synchronous motors, three-phase AC motors, single-phase AC motors, AC motor starters and speed control, DC motor starting and speed control, motor enclosures and maintenance. Okay, that's what we're going to be looking at overall. Okay. The first protocol is three-phase AC motors synchronous. Three windings connected to a three-phase AC supply form a rotating magnetic field in the stator. Okay. This magnetic field travels at synchronous speed n. Its speed is determined by the frequency of the AC supply and the number of poles per pairs, or pairs of windings, if you like. Okay. Now, this information cannot be overstated at any point in time, and the more you hear it, the more you're likely to understand it. Okay. Do some of your own research. Look at what information has been given. Do a little bit of reading for yourself. Bedtime reading preferred. Okay. This type of motor runs at constant speed. Okay. Or synchronous motor. Now, all I'm showing you here is the rotor bar brush. Okay. Brushes that comes out to your slip rings. Okay. The external DC power supply, and that is your internal coil. Okay. Original synchronous motors had copper coils in the rotor and stator. The stator has a three-phase AC supply and the rotor has a DC supply. The DC supply was delivered via slip rings and carbon brushes, but with new type of motors coming into play, you look at what changes that they've made and look at what new motors is being utilized. Now I think I did a little bit of work on this some time back, but I'll have to go and look it up again. But bear with me, just look at what is on the market currently now, okay? That is in your interest. A synchronous motor is non-self-starting. It needs its rotor to be rotated to synchronous speed by an external motivator, i.e. another motor, before it would run. Okay? Okay, let me just pull that back. Now these motors can only run at synchronous speed or they would stall. Now be sure you understand what synchronous speed is, okay? And I did a little bit of this the other day as well in another video, but I'm not giving up on you. This complicated system was overcome by the development of the induction motor. Now you can see here where we had this synchronous motor and we needed an external motor to start it, an external source. We now found a different way of getting a motor to start, and we call it the induction motor. Okay. Now induction motor. So I just had to lift my camera up a little bit and take it back because I was a little concerned about being in focus. Okay. Now induction motors replace the copper windings in the rotor with a cage design called a squirrel cage, and that is our cage design. Okay, that's what it looks like. Okay, and that there is what's in here. Okay. This squirrel cage was constructed from aluminium with shorting rings at each end and clad in laminated silicon steel. The laminations are skewed to aid starting and quieter running. Okay, skewed mean that they're set at an angle, just set off angle. They're not straight, they're skewed. Okay. I'm just going a little bit, make sure you can see it. Okay, and let me just pull back a bit so I can take it into full view. Okay. Okay, let me go down a little bit and turn to the angle. Hopefully I can get him into view as well. Okay. Yes. Okay. Good. Now cage rotor motors are quite efficient and do not require brushes or slip rings. They operate purely by magnetic induction. You remember you saw earlier a bar magnet and it had a north and south pole. What happens is that we have a north and south pole in the same area, but because one opposes the other, you get rotation generated by the motor. Okay, that's a simple explanation. Okay, the rotating magnetic field in the stator induces current magnetism in the cage rotor, which in turn is attracted to the stator. As the magnetic field in the stator is rotating, the attraction between them causes the rotor to move. Okay. induction motor wound rotor. And I won't go into far because I want to make sure that it stays in focus, okay? Wound rotor design has the advantage of a far higher starting torque. Starting torque. Sorry. A wound rotor design has the advantage of a far higher starting torque. It's okay, I was just distracted by my quoting. This is achieved by adding external resistances to the rotor windings via free slip rings or brushes. Okay. Torque is thus controlled by changing the resistance of the rotor windings. Current and magnetic flux also change as the motor runs up to speed on the load. The system does have the disadvantage of a more complex design with copper windings, brushes, slip rings, and external resistance starter. Okay. Both wound and cage induction motor rotors cannot run at synchronous speed, but slip behind it at between 2 to 5%. If excess load is applied, slip increases and the motor would stall. Single-phase AC motors. Unlike three-phase motors which are self-starting, single-phase motors are not. A single-phase supply produces a pulsating magnetic field, unlike the rotating magnetic field that a three-phase supply produces. Single-phase AC motors require an additional winding in the stator. This is called a start winding. Okay. The start winding will be electrically out of phase with the run winding up to around 40 degrees. So you can see here the start winding is out of phase already in order to give the impression that it is pulsating or a rotating magnetic field. In short term, it's trying like to fool the motor. This produces a two-phase rotating magnetic field and the motor can self-start. Okay. At about 80% of full speed, the start winding is disconnected from the circuit by a centrifugal switch. The motor now has inertia and continues to run. If the start windings were to remain permanently energized, it would soon burn out. Split phase AC motors. Now start winding, let me see if I can go in close to it. Yeah. Start winding, rotor, run winding, centrifugal switch. Okay. Start winding has slightly higher impedance than the run winding. This difference in impedance gives approximate 40-degree phase difference between start and run windings. and it is that difference which gives the impression of an alternating waveform, or cycle I should say, okay, or more appropriately the alternating magnetic field. The phase difference sets up a two-phase rotating magnetic field instead of a single pulse field. The motor can now self-start. Now remember, it will not run on a single pulse field. We need that second start field for the motor to actually run, and that is vital. Without that, nothing would happen with the motor. Okay. When rotor reaches 80% of full speed, the centrifugal switch disconnects the start windings, simply as before. Okay. This design has low start torque and runs at constant speed. And here we are. Okay. This motor cannot be speed controlled due to the centrifugal switch. This centrifugal switch prevents the motor from being speed controlled. To reverse direction, swap start or run winding connections. Goodness me. Okay. Now what am I looking at here? Let me just... It's okay, I'm just trying to make sure that I got you in focus, because right, split phase capacitor start AC motor. Again, similarly, run winding and centrifugal switch, and here we have now the difference. We have a capacitor in the circuit. Okay, that is now the fundamental difference. So don't ignore that. Look for this, what it does. Okay, a capacitor in series with the start winding gives a better phase displacement of up to 90 degrees. So here we have a phase displacement of up to 90 degrees, whereas before we had a displacement of only approximately 40 degrees. Okay, in respect of the angle required in order to generate rotation. Okay, that's what I'm going to look at it as. But again, remember, it's from my perspective. You need to adapt your own style of learning and interpreting the information. This displacement gives a higher starting torque. Okay. This displacement gives a higher starting torque. Okay. Now at 80% of full speed, a centrifugal switch disconnects the start winding and capacitor. So here you can see the centrifugal switch disconnects the start winding and capacitor. Okay. Capacitor can be 250 volts rated, as it is not always energized. Now the reason for the 250 volts rating is that it's the voltage that the capacitor will be able to handle main supply voltage. But some capacitors will need to be at a higher voltage to handle certain charge excess or high voltage applicable. So you can get capacitor up to 450 volts, maybe 800 volts handling capacity, or if not higher in some cases, depending on the purpose of the capacitor. Okay. This motor cannot be speed controlled due to centrifugal switch. It runs at constant speed. Okay. To reverse direction, swap start or run winding connections. Again, split phase permanent capacitor AC motor. And here you can see we have a permanent capacitor here. That's what we're looking at and talking about. That's the difference in respect to each motor. You'll see that each motor has something very small that makes it different to any other motor, okay? So bear that in mind. Same design as capacitor start motor, except there is no centrifugal switch, okay? Capacitor must be 400 volts rated as it is permanently connected, okay? Now 400 volts rated or higher in order to handle the voltage that can be generated within that circuit, okay? Auxiliary start winding is also suitable rated for continuous operation. The motor has high start and running torque due to capacitor given 90-degree phase displacement and can be speed controlled, okay? It runs at constant speed under moderately changing load conditions. As long as the load change is not too great, it will run as such. To reverse direction, swap start or run winding connections, okay? Now, split phase motors are used in fans, pumps and other load applications. That's for you to find out further use of these items, okay? In all cases, the capacitor is mounted to the motor casing, okay? Now, AC motor starters and speed control. Now look at the side of this motor, and I've been fortunate enough to work on these things myself in my younger years, okay? But scary things there can be. Working on these things, you have to be very careful. If you see any of these ever overheat or burn out, basically the smell is tremendous. DOL, direct online single and three phase. Star Delta starter. Auto transformer starter. Soft start. Variable frequency drive, okay? Oh, sorry. Rotor resistance starter, wound rotors. All motors over 0.37 kilowatts must be connected through a suitable starter system. Regulation 552.1.2 and 3. Now bear that in mind, that ensure that this regulation is still applicable. As such, you will need to confirm that with the IEE regulations. Do not ignore this and do not take this as read. You have a responsibility and a duty of care to ensure safety at all times. That is your job. Make sure you are compliant with the IEE regulations. Now, let me see if I can go into it. This is a diagram I would like you to draw out. Draw it for yourself. You'll be surprised what skills you actually learn when you actually draw this out. But that's for you to do. DOL direct online starter. Can be single phase or three phase, okay? Only to be used for motors below 5 kilowatts, okay? Different coil voltages are available. Provides no volts coil safety operation. Hold on contact A. uh, I'm going to let you look into that yourself a little bit more. When it says hold on contact A. Okay. Here, these would be your overloads. Okay. Has momentary action on start switch. Okay. Has adjustable motor overload coils D. Oh, sorry, let me just go back a little bit. I didn't want to finish that. Okay. Has adjustable motor overload coils D. Okay. Now, I still recommend that you draw that out. Okay. Now, mains off. Now, this is an interesting function here. The thing is that if either phase becomes overloaded, these trips out, or they will actually burn out, okay, with the excess current that flows. Okay. Now this here is the mains off, and what we're actually showing you here is the state is when we push the start button, what happens to the motor. So we're going to push the start button, okay. So let's run that and see what happens. Mains on, okay. Hang on a second, I thought. No. Main supply on, yes, thank you. Okay. Now this should actually rotate. Oh, okay. But you can see what's happening now with regards to the motor. And let me bear with me. Come on. I'll run you before you work this kind of. But anyway, you can see what's happened here. When I push the start button, so where come here? Okay. When I push the start button, okay, it's not doing what I want it to do. But three-phase motor overheating, okay. So motor overload coils activated. So theirs will trip out and protect the motor from burning out. Okay. But sorry, hang on, let me just see what I've got here. Go back a bit. Okay. And let me just press done. Comes. Okay. It's okay, I'm just trying to go back to the start, but it's not letting me do that. It's okay, right, anyway, you get the idea, and some of the work you'll need to do yourself. This is the motor start contact coil. Got you, I think. 1 second, bear with me for a second. Yeah. Now, this should actually give me main supply on. Okay. And if I go back, I should see a state where the main supply top button pressed. Okay. Main supply on. 1 second, bear with me. Go back. Main is off. And that's always no state. Okay. When you press the start button, so you go back one, because when I press the start button it should give me a mains on, and when I press the start button it should connect me to my motor. My motor now should be running basically. Okay, then it should just show me the phases that stop button has been pushed. Okay, and here is our stop button being pushed. Okay, which stops the motor. We can look at something else as well. Mains by on, and then I think it gives me other options to look at what happens when the overload coil operates. Okay, that's what we're looking at. Okay, and let me just run that through. Motor overheating could be the bearings. Okay, bearings tend to wear out, so they need good lubrication, but normally it's something to do with the motor itself. Okay, and press again, you see that giving me motor overload, switch off the DOL starter. Okay, and we are enabled safe. And DOL components, well, start button normally open, stop button normally closed, remote start and stop buttons can also be fitted, contactors switch current flow to motor, coil controls contactors, overloads detect excess current flow to motor, thermistors may also be installed in motor windings. Okay, motors in excess of 5 kilowatts have very high start-up current, so alternative methods must be used. Compare DOL to a 1-speed gearbox on a car. Simple analogy, okay? Okay. I'm always amazed at how the manufacturer makes these things so sensitive to so much excess of current. Quite fascinated by that, actually, I have to admit. And this is our Star Delta starter. Used for AC motors above 5 kilowatts. Okay. Motor has 6 terminals to allow its windings to be connected to the starter as either star or delta. Motor is started in star, voltage, current and torque are all reduced. Interlock prevents motor trying to start in delta. When motor is up to speed, starter switches connections over to delta. Full voltage, current and torque are now present. Changeover can be manual or automatically timed. Electrical and mechanical interlock prevents a simultaneous star and delta connection. Compared to a 2-speed gearbox on a car. Okay, very nice, thank you. Let me just go back a bit, make sure that I can get you all in. Okay. Auto transformer starter. And again, let me just make sure you can see that. Uses a multi-tapped transformer to control voltage and current torque as motor starts. Smoother control compared to 2-position star delta starter. Only requires 3 connections to the motor. Interlock prevent motor being started in wrong transformer tapping position. Contains same safety features as DOL. Compared to a 4-speed gearbox on a car. Now you're trotting. Soft start. Now soft start refers to the electronics and thyristor control system that has now come on the market, and even more precise equipment, so forth, and software as we continue development for space exploration. We're discovering other things as well. Okay, so soft start. Uses thyristors to control voltage and current torque as motor starts. The thyristor is an AC switch. By controlling the firing angle of the thyristors, AC voltage can be controlled. Programmable starters can be configured for different motors uses, etc. Have the ability to precisely control acceleration and deceleration of induction motors. Has same safety features as other starters. Compared to a silky smooth automatic gearbox on a car. It's not on the... It's okay, I'm just trying to see if I've got the reflection on in my computer, but no, it's only in my it's on my camera. Okay, variable frequency drive, and here you are now driving or bringing in controls. Unlike a soft start, which controls voltage, a variable frequency drive VFD controls frequency. Synchronous speed is determined by frequency. Mains frequency is converted to DC. Discharges reservoir capacitor and provides high voltage DC. This is converted to AC at variable frequencies determined by the drive and is programmed. I should say. Starters provide precise speed control and are fully programmable. Drives are selected based on motor size. Has same safety features as other starters. Okay. Compared to a silky smooth automatic gearbox on a car, simple analogy. Ignore my analogies; they're just for that purpose. Okay. Rotor resistance starter. Used on wound rotor AC motors. These motors are required to start under high load conditions. External resistances are connected in series to the rotor windings. As motor starts up, the external resistances are reduced in value until they no longer add to the rotor resistance. They come disconnected completely. Okay. This method provides high starting torque and current that can be gradually reduced as motor speeds up and is assisted by its own inertia. Has same safety features as other starters. Okay. DC motors theory, DC motor armature series universal motors, shunt motors, compound motor short, long, DC starting and speed control. Okay. Let me pick your part. Okay. Stator can be permanent magnet or copper windings. Armature is the rotating part of a DC motor. Armature has its own windings terminated at commutator bars opposite each other. Carbon brushes connect DC supply to the armature coil's windings while it turns. Bearings support armature when it is inside the stator. Okay. Series universal motor, Norway showing you here is the armature to speed. Armature current to speed. Okay. Can work on either AC or DC. Oh, and this is the series universal motor, okay? All windings, field, and armature are in series with each other. Speed is dependent on load. The motor can be damaged if run with no load. To change rotation, swap connection of brushes or field windings. High start torque. Used for drills, vacuum cleaners, DC, trains, etc. Can be speed controlled. Oh goodness me. Now I would recommend that you draw out these diagrams. They're so valuable in providing you with information of different types of motors because most of them are so similar. It's important to recognize and identify each in turn for yourselves. Okay. Field and armature windings are in parallel with each other. Okay. And this is the shunt motor. Speed is fairly constant under load or no load conditions. %5 would be a 5% slip, would be my interpretation of that. Okay. You may have a different interpretation. Low start torque, best to remove load on start up. To reverse rotation, swap brush or field connections. Used for constant speed applications with varying loads, machine tools, conveyors. That's the use of it, okay? Okay, pull back a bit. I don't want it going out of focus. Can be speed controlled, okay? And compound motor. And you can see the various types of compound motors. Cumulative compound, differential compound, and interpole compound. Okay. Compound is a combination of series and shunt. Has the best operating characteristics from both. Good starting torque and constant speed under varying loads. Okay. Can be speed controlled. Available as short shunt and long shunt to give different characteristics. This is motor starting and speed control. Okay. Now this is for you to look up yourselves. Okay. This would be that's the handle that you will pull. Okay, you would pull the handle to start it, basically. Okay. In position N, start. Well, yeah, you pull the handle, and you would begin to reduce the load as you get closer and closer. In position N, start, the contact arm allows full current to flow through the field windings. However, armature current is limited by 4 resistors. Well, 4 resistors. They are resistors actually. The motor begins to build up speed whilst current is controlled. When speed stops increasing, contact arm is moved to next position, reducing armature resistance and increasing shunt field winding resistance. Okay. Repeat until contact arm is in position 4. Series resistance has been removed from armature and series resistance is in circuit with field windings, short shunt configuration. Okay. Electromagnet 4 holds contact arm in 1 position. If power is lost, arm returns to off position M for safety. Motor cannot automatically restart. Okay, so we have built-in safety measures in regards to our DC motor starting and speed control. Available resistance in series with field winding shunt motor or in parallel with field winding series motor is one method of speed control. Motor enclosures and maintenance. Different motor enclosures are available depending on the environment. Some motors are fan cooled, others may have piped ventilation. Okay. Flame-proof enclosures, okay. Terminal box and motor have X covers with wide machined flanges and captive fasteners. This particular motor is also fan cooled, indicated by the fins around it and the fan cover at the back. Connections to motor made with flexible conduit must have a separate earth conductor installed. Regulation 543.2.1. Now make sure that the regulation is still concurrent with today's requirement unless they've changed it. And you must confirm that with the IEE regulations. Do not ignore that factor. Sorry about that. That damn thing always come up from the least expected. Mineral insulated cables should have a loop formed before final connections to the vibration to the mineral insulated cables should have a loop formed before final connection to the motor. This will absorb any vibration and allow for motor adjustment, i.e. drive belt retentioning. Now you need to leave a long loop or double loop basically in regards to mineral insulated cables, because if it breaks or there's a fault, you don't want to be running that 200 meters run again. You need to be sure that you have enough there to terminate as required. Maintenance bearings, okay, and here's your bearings. You can see here that bearing is crushed. I mean, that is what failed completely, and that motor you can see is burnt out. That's gone. What we normally do here is lubrication, okay. Overloading a motor can cause bearings wear, top picture, okay. Bearings require regular checks, yes. Some bearings and shafts require greasing regularly using a grease gun, bottom picture, okay. I've just shown you. Dust damp can cause bearings to wear if motor cover becomes loose or are missing, okay. And maintenance, alignment and vibration. You got to make sure that this is in line, otherwise you get vibration which will shatter the motor, okay. Okay, couplings, pulleys and belts and other drive shafts should be checked to regularly for security and alignment, okay, as in your top picture, okay. Belt drives can be retensioned by adjusting motor slide rail. Bearing wear and vibration can occur if fixings or alignments are not correct. This leads to other problems also. Yep, it does. Bearings will eventually wear through normal use. Ultrasonic measurements can detect the early signs of bearing wear, saving costly downtime. Okay. Maintenance. Slip rings and commutators require regular checks and maintenance. Okay. Brushes should be checked for damage, wear, excess arcing when running. Overloading the rating of a motor can lead to overheating and winding damage. Bottom picture, and you then need to replace the winding completely, okay? And that's quite expensive. Regular planned maintenance can eliminate most of these problems. Motors are very reliable machines and can provide many years of service. Yes, they are. Okay. Well, thank you. I hope you found this useful. Have a good day. Bye-bye.